Hello everyone. In the last video, we were discussing about the characteristics of the deadlock to occur. First one we discussed mutual exclusion, then hold and wait, then no preemption, and the last one is circular wait. So let's proceed with circular wait. Circular wait is a condition in which suppose there are n number of processes in the system and process P0 is waiting for a resource that is acquired by process P1 and process P1 is waiting for a resource that is acquired by process P2 and process Pn minus 1 is waiting for a resource that is acquired by process Pn and in turn Pn is waiting for a resource that is held by process P0. So it makes a cycle from process P0 to Pn and all are waiting for a resource that is acquired by the other processes. So this condition is called a circular wait and which leads to deadlock. So alone no condition can lead to deadlock. These four conditions that we have discussed, mutual exclusion, then hold and wait, then no preemption, and then circular wait. These four conditions simultaneously when happen in the system, it is the condition of deadlock. Then we are having a concept resource allocation graph. Actually, resource allocation graph is nothing but a graphical representation of the system, its resources and its processes and how they are working with each other. That means whether one process is requesting a resource or the particular resource is allocated to some other process. So in this resource allocation graph, we are having a set of vertices V and a set of edges E. Now V is divided into two types, which is holding the processes and resources. P is a set which is holding all the processes in the system from P1 to Pn, and R is the set holding the m number of resources, total number of resources that are available in the system, R1 to Rm. Then there are two edges in the system. First one is request edge. Request is a directed edge from a process requesting for a particular resource to the requested resource, from a process to the resource which is requested by the process. And assignment edge is that directed edge which demonstrates that particular resource is assigned to that particular process that which is connected through the edge. Now these are the symbols that are used in resource allocation graph to demonstrate various situations. Circle is used to demonstrate a process. A resource is represented by a square and internal small squares in the square are representing the instances of a particular resource. For example, a particular square having 4 internal squares is the resource having 4 instances of itself. Then a process directed to a resource indicates that process Pi is requesting an particular instance of the resource Rj. Then if Pi is holding an instance of Rj, it means Pi is the process which is holding a particular resource with it for its execution. Now this is the example of resource allocation graph in which there are 3 processes P1, P2 and P3 and 4 resources R1, R2, R3 and R4. Now resource R1 is requested by process P1 and is assigned to process P2. Similarly, resource R2 is assigned to process P1 and process P2 because resource R2 is having two instances, so can be allocated to two processes at the same time. Now, resource R3 is requested by process P2 for its completion, but it is assigned to process P3. Resource R4 is not assigned to any process and neither it is requested by any process. So this is a resource allocation graph example through which you can demonstrate the situation in the system. And this is a resource allocation graph with a deadlock. In this you can see process P2 is assigned with an instance of resource R2 and is requesting an instance of resource R3. Similarly, process P3 is assigned with the instance of resource R3 and is requesting an instance of resource R2. Because R2 resource is having only two instances which are assigned to process P1 and P2, and R1 is assigned to P2 but is requested by P1. Similarly, R3 is assigned to P3 but requested by P2. And R2 is assigned to P1 and P2 but requested by P3. So this makes a cycle in the system which is called a circular wait condition, and hold and wait condition also is there in the system. So it leads to the deadlock in the system. This is a resource allocation graph with a cycle. A cycle is there between resource R1, process P3, resource R2 and process P1. It is a cycle, but there is no deadlock because resource R1 is having two instances. One is assigned to P2 and another is assigned to P3. So because resource process P2 doesn't require another resource for its execution, so it will complete its execution with resource R1 and will release the R1. When R1 resource will be released, its instance will be allocated to process P1 which is requesting it, and it is having an instance of resource R2, so it will complete its execution. Similarly, process P3 is assigned with resource R1 and is requesting resource R2, but resource R2 is one is given to P1 and another instance is given to P4 process. Now P4 process doesn't require any further resources to complete, so it will complete its execution and free up the resource R2, and it will be assigned to process P3 and all the processes will be completed successfully. So there is no deadlock in the system. So these are some basic facts about the graph. If a graph contains no cycle, if there is no cycle in the graph, then certainly there is no deadlock in the system. Yani ki system is in the safe state. And if a graph contains a cycle, then there are two conditions. If there is only one instance of every resource in the system, single instance of the resource, then certainly it will lead to deadlock. Other condition is if the resources are having multiple instances, then there is a possibility whether the system can be in safe state or it may be in the deadlock state. And these are some briefly defined methods that how we can handle when the situation of deadlock occurs. So for handling the deadlock, first one is the situation to ensure that system never gets in the deadlock state. We have to ensure, we have to manage our resources and processes such that no deadlock happens in the system. So we have to assign the resources to those processes only which doesn't lead to deadlock situation. So we have to take care about that thing. If the system